Hi everyone, my name is Kadir Sinar, and this is my presentation for assignment 4, where I explore overfitting, regularization, and then data augmentation using like convolutional neural networks with the CIFAR10 dataset. So first, I import necessary libraries, the Matplot, Tensor, Keras, and I use the CIFAR. And I use the CIFAR datasets. So as a the second step, I load the CIFAR datasets here and the shape of data. So I printed out the shapes of the training dataset, just to confirm everything loaded correctly. So the training data has 50,000 images and test data is 10,000. And I displayed 10 example images from the training set. As you see, frog, truck, deer, automobile, bird, horse. Each label with its class name. This gives us the better idea of what kind of images the model will be working with. So before training, I normalize the image pixel values to be between 0 and 1 and apply one hot encoding to the labels. I also create the validation set using 10,000 samples from the training data to monitor the model's performance during training. So, and then I create a basic CNN model without regularization yet. So I started with a basic CNN model with the convolutional layers, followed by a flattening layer and two dense layers. The final output layer uses softmax for classification into 10 categories. And you can also see validation accuracy, validation loss here. I compiled the model using the ADAM optimizer and categorical cross-send therapy loss. Then I trained for 20 epochs with a batch size of 64 epochs and batch size of 64 here. And then I plot some of the things for validation accuracy to address the overfitting here. To address the overfitting, I build a second model using L2 regularization and dropout layers. This helps the model generalize better by preventing it from relying too heavily on any one feature. After training the regularized model, I plotted the accuracy and loss again. The gap between training and the validation performance was smaller compared to the first model, showing better generalization. That means our training works well. You can see here the validation accuracy under the training accuracy, which is sign of the loss of. Then I start data augmentation to improve model even further. I used data augmentation. I added random rotations, shift and horizontal flips to the training images using the image data generator. You can see here this is the accuracy graph after another training, and this is the data augmentation. You can still see validation accuracy and validation loss with 20 epochs. So next, I tested on over parameterized model with a lot of more layers and neurons. It was able to fit the training data very well, but again I started to overfit, especially when we will look at the validation loss. So finally I compared the validation loss of the over parameterized model with a regularized model. As expected, the regularized model performed much better on the validation set. This is the validation accuracy, validation loss here, and this is the final graph. When you see it on here, you'll see the difference. So in conclusion, this assignment clearly showed how overfitting happens in the deep learning models and how we can combat it using regularization techniques like L2 and dropout, as well as the data augmentation. Thank you for watching. Have a great day.